Alright, in the last lecture we have learned common operations that can be performed on stack using array implementation. Now in this lecture we will implement stack using linked list. So let's see how it works. So first we are going to start creation of stack. So to create a stack using linked list, firstly we need to create an object of single linked list class. So when we create an object of single linked list class, it basically creates a blank head. So the reference of this head right now is null, because there is not any node in this linked list over here. So by creating an object of linked list, we have successfully created stack using linked list. So once we have created a blank stack, the next thing that we are going to do, we need to push elements to this stack over here. So let's see how we do that. So the first we create a blank node over here, then we assign value to it. Then we change the head reference to point to this node over here. Now as you can see, our head reference is null, so we have to update the head reference to the physical location of this node that we created over here. Now the physical location of this node is 111, so we are going to set head to 111, and with this a link between head and node 1 is created, and this node 1 is pushed to our stack over here. Now if we want to insert one more element to this stack over here, we are going to call push method. So each time we are calling push method, we are going to insert a node at the beginning of single linked list. So here we are going to create a blank node, and then we are going to assign a value to it. Now you can see that the physical location of this newly created node is 222. So to add a node at the beginning of single linked list, the first thing that we are going to do, we are going to update the next reference of new node to point to first node. Now the first node's physical location is 111, so we are going to update next reference of this node to 111. So with this we are creating a link between this newly created node and first node over here. Then head has to point to this first node, so that's why we are going to update the head reference to the physical location of this node, which is 222, and a link between head and the first node over here gets destroyed. Now with this, a new element will be pushed to the stack over here. Now you need to keep in mind that whenever we are pushing an element into the stack using linked list, we are inserting this node at the beginning of linked list over here. Now if we try one more element one more time, so here again we are creating a blank node, then we are assigning a value to it, then we are setting the next reference of this node to point to first node over here. So now first node is 2, which is located at the location of 222. We are going to update 222 to the next reference of newly created node, and with this a link between them is created. Then we have to update the head reference to point to this node over here. Now if I set 333 to head, it's going to create a link between this node and newly created node, and a link between head and first node gets destroyed. Now after doing so, this node is successfully pushed to our stack over here. This is how push method works in stack in case of linked list. Now let's continue to look at pop method. Now as you remember, when we talk about pop method, we said that the pop method returns the top element and remove the top element from the stack. Now in our case, the top element is 3, which is the first element in our linked list. So this means that every time we are going to delete the first element from the single linked list and return its value. Now we know that to delete an element from the beginning of linked list, all we have to do, we have to set head reference to point to the next node. Now the next node's physical location is 222. Now if I update the head reference to 222, it's going to create a link from head to this second node, and a link from head to the first node gets destroyed. Now you can see that this node is not referenced by any given node, so this means that it can be removed from the linked list, so it will be popped out from the stack over here. So with this, we have successfully deleted the top node from the stack, and this node is returned to the console. Now if we try pop method one more time, in this case also you see that this element, the node 2, becomes the first node over here, so it's going to return this one because it is the top element in our stack over here. Now here again we are going to update head reference to point to the next node, and a link between head and this node gets destroyed, and this node becomes eligible for garbage collection, so we are going to return this node, and this node will be deleted from the memory. As you see, it's popped out from the stack over here. Now let's continue to the next method. The next method is pick method. Now when we talk about pick method, we said that it's going to return the top element always, but it's not removing that element from the stack. Now in this case, the top element is 3. Now if you look at 3, you see that 3 is located at the beginning of linked list. So this is the first element in our linked list. So if we return the head value, it's going to return the top element in our stack over here. So in case of linked list, when we are calling pick method, it's going to always return the head value over here. So this means that in our case, if we run pick method now, it's going to return 3. So if we run it multiple times, it always in this case return 3 because 3 is not removed from the linked list over here. Now if we continue to the next method is empty method. Now if the head is equal to null, we are going to return because in this case it's empty, because if our head is not referenced to any node, it means that we don't have any node in our linked list. So this means that in our stack we don't have any elements, so it's going to return true, otherwise it's going to return false. So if our head is equal to null, it means that we have to return true in this case. Now the next operation is delete method. Now we know that delete method in stack is responsible for deleting the stack from the memory. Now if we want to delete the stack from the memory in case of linked list, all we have to do, we have to set head reference to null. So if we set head reference to null, all elements become eligible for garbage collection, so garbage collector will come and destroy these elements from the memory. Now here, you might notice that we have not used isFull method because in case of linked list, the stack will not be full. That's why we are not using isFull method over here. So the size of stack in case of linked list is variable, so we can add how many elements that we want in our stack over here. So that's why isFull method in case of linked list is not eligible. Now with this we have come to the end of this lecture. So in this lecture I have shown you how can we perform different methods on stack using linked list. Now in the next lecture we are going to implement these methods in practice. So see you in the next lecture.